I am going to report about current limit starter for DC motor. DC motor, unlike other types of motor, has a very high starting current that has the potential of damaging the internal circuit of the armature winding of DC motor. If not restricted to some limited value, this limitation to the starting current of DC motor is brought about by means of the starter. The starting methods of DC motor is facilitated by means of a starter, or rather a device containing a variable resistance connected in series to the armature winding so as to limit the starting current of DC motor to a desired optimum value, taking into consideration the safety aspect of the motor. A starter allows a DC motor or a DC motor control device to turn on or off. Starters are used for starting DC motors and also suggest the alternative methods that can be used to construct a DC starter to overcome the limitation of the previously existing starters. An electrical motor is a machine which converts electric energy into mechanical energy. Its action is based on the principle when the current carrying conductor is placed in a magnetic field. It experiences a mechanical force whose direction is given by Fleming's left-hand rule. The starting of a DC motor is different from the starting of all other types of electrical motors. DC motor is self-steering motor. If armature and field of DC shunt motor are energized together, large current is drawn at start but the torque builds up gradually as the field flux increases gradually. To improve the torque per ampere of line current drawn, it is advisable to energize the field first and later the armature. The starting current is given by I is equals to V over Ra, and hence to reduce the starting current to a safe value, either the voltage can be reduced or armature circuit resistance can be increased. The back EMF is developed as the motor armature starts to rotate in the presence of magnetic field. This also means that the back EMF is initially zero and develops gradually as the motor speeds up. Therefore, the total motor voltage is given by the equation V is equals to EB plus IA times RA. At starting EB is equals to 0, so the equation would be V is equals to IA times RA, and IA is equals to V over RA. That's our figure for DC motor. Starters are used to protect DC motors from damage that can be caused by very high current and torque during startup. They do this by providing external resistance to the motor, which is connected in series to the motor's armature winding and restricts the current to an acceptable level. Starters can be of several types and requires a great deal of explanation and some intricate level understanding. But on a brief overview, the main types of starter used in the industry today can be illustrated as the 3-point starter and the 4-point starter are used for the starting of shunt-wound DC motor and compound-wound DC motor. Series wound DC motor starter using no-load release coil. First is 3-point starter. That's our figure for 3-point starter. So a 3-point starter is a device that helps in starting and running of a DC shunt motor or a DC compound motor. 3-point starter limits the starting current to allowable lower value. A 3-point starter is a variable resistance integrated into a number of sections The contact points of this starter are called as studs, which are shown separately as off, 1, 2, 3, 4, 5, then run. Then the name 3-point starter has been given to the starter as it has 3 main points, which are referred as: first is line terminal connected to positive supply. Second is armature terminal connected to armature winding. Then the third is field terminal connected to field winding. Then next is a 4-point starter. Then our figure for 4-point starter. The 4 point of a 4-point starter are as follows: line terminal connected to positive supply, armature terminal connected to armature winding, field terminal connected to field winding, then ang additional point connected to electromagnet. A 4-point starter is identical to a 3-point starter, but the addition in the device is a terminal that links the supply to the electromagnet, which brings about changes in the functionality of the device. The terminal is necessary because higher speed of the motor reduces field current through terminal, so that the handle is unable to remain in run position. Thus, it must be ensured that electromagnet always produces a force which is strong enough to hold the handle in its run position against force of the spring under the operational condition, such that the current is adjusted by the electromagnet with the help of fixed resistance connected in series with the electromagnet using the 4-point N or the terminal. Apart from this difference, the 4-point and 3-point starters are similar always. The current is divided into 3 parts. First part is current flows starting resistance and then through armature. Second part, current flows through the field winding. The third part, current flows electromagnet in series with a protective resistance. This is where the 4-point starter differs in its operation from 3-point starter. Otherwise, both 4-point and 3-point starters are almost similar and are also used for the similar purpose for limiting the starting current and protecting the DC shunt wound and DC compound wound motors. All of these play a very significant role in limiting starting current of DC motor for proper starting and running of the DC motor and are described vividly under their respective subheadings. So our figure for series motor starter, no load release. That's all. Thank you and God bless.